Let's walk through an example of how the sliding window approach works for this problem. So we have our array nums, and we have a target value 7. We iterate through the array and keep track of two indices, the left and the right window. And whenever we see a contiguous subarray that sums to greater than or equal to s, we keep track of the length of the array and store that into answer. And eventually, after iterating through the entire array, we want to find the minimum contiguous array, subarray, that sums to greater than or equal to 7. Right now, both s and r start at index 0, and so we have that our sum of this subarray is 2, which is less than 7. So that means it isn't a valid subarray, so we have to increment r. Now, at this point, our subarray sums to 5, which is still invalid because it's less than 7, so we increment again. Now, our subarray sums to 6, still less than 7, so we increment r. And now our subarray sums to 8, which is greater than or equal to 7. So that means this subarray right here is a valid subarray, and its length is 4, which is less than infinity, so we can replace that with 4. So now that we had a valid subarray, we can kind of zone in on a smaller subarray to see if it'll still be valid by incrementing L. So now the subarray current sum is 6, which is no longer valid, so we increment R again. So now we get a sum of 10, which is greater than or equal to S, and this subarray length is 4, which is already what we had as the answer. So there's no need to update that, but we can always close in on the subarray to see if this is still valid. And because it sums to 7, that means it is greater than or equal to S. And so this subarray length is 3, which is even smaller than 4, which is a better answer. Now we move L again, and we see that we get a subarray that sums to 6, which is less than 7, so that doesn't work. So that means we increment R. And here we get a subarray that sums to 9, which is a valid subarray. And so we can record its length as 3, which we already have. So we can increment that again and see that this is also a valid sum because it's greater than or equal to S. And here the length is 2, which is less than 3. So 2 is an even better answer. And then now because we've kind of finished iterating through the array, well, we can increment L again and see that we have 3, which is less than 7. So now that we've finished iterating through the array, we see that our best answer is, in fact, 2. Now let's walk through the solution in code. So I've outlined the structure in the comments here. So this would be a good time to pause and try it out yourself. Okay, so first we take care of the edge case in which nums is equal to null, or nums.length is equal to 0. Okay, so now we initialize the left and the right window to be starting at index 0, and the answer to be positive infinity, as seen in the example we did earlier, and then the current sum to be equal to 0 before we start iterating. Okay, so now we slide the right window to the right as long as current sum is still less than target. And we add nums r to current sum each time we slide the right window. And then while cur sum is greater than target, so while we have a valid subarray, we calculate whether the answer is going to be less than the length of the current answer. So that would be r plus 1 minus L would be the new length. And then we update current sum after sliding the left window forward. Okay. And then we return answer is less than integer dot max value, meaning we've updated the answer from here. So we know that there was some valid subarray, in which case we can return answer. else we return 0 if we did not find a valid subarray summing to greater than or equal to target. Okay, so now let's submit. All right, let's troubleshoot. Here we go. Current sum has to be greater than or equal to target. So it's still valid if current sum is equal to target. And there we go.